Hello everyone, we are Group 4. My name is Dai Shixing and I'm responsible for 2015 to 2016 Semester 1, Question 3A, the third part. In the question, the customer's waiting time for collecting food and drinks at the coffee kiosk follows the normal distribution approximately, with a mean of 4 minutes and a standard deviation of 1.2 minutes. In the third part, we need to calculate the probability of at least 3 out of 5 randomly selected customers will have waiting time more than 5 minutes. So we can let X be the randomly selected customer's waiting time, and it follows the normal distribution. Then X follow normal with mean of 4 and standard deviation of 1.2. The probability that X larger than 5 equals to 0.2033. And we can let Y be the number of customers have waiting time more than 5 minutes, and Y follows binomial distribution. Then Y followed by nominal with n equals to 5 and the probability equals to 0.2033. And we need to calculate the probability of at least 3 out of 5 randomly selected customers will have waiting time more than 5 minutes. Therefore, the probability with Y equals to 3 plus Y equals to 4 plus Y equals to 5 equals 0.0605. Therefore, the probability of at least 3 out of 5 randomly selected customers will have waiting time more than 5 minutes is 0.0605.
Here comes question 3b. It is known that 0.01% of people will be affected by a certain infectious disease after vaccination. And among all people having vaccination, 500,000 people are selected at random. And we are going to calculate the probability that 51 or 52 people will be affected by the disease. So firstly, let X be the number of people that will be affected. Then N is equal to 500,000 and P is equal to 0.0001. And yet, after substituting the number into the equation, we cannot get the answers since the numbers are too large. So we can use the approximation to solve the problem, where lemma is equal to m times p, which is 50. And after putting the numbers into the equation, we can get the answer, which is 0.1083. So the probability that 51 or 52 people will be affected is 0.1083. Thank you.
Now, let's move on to question A1. 80 customers are invited to try a tea and 64 of them think the level of sweet is acceptable. We should find 95% confidence interval for the population proportion of customers who accept the level of sweet. For this question, N equals 80, X equals 64. So the p hat equals X over N, which is 0.8, and the q hat equals 1 minus p hat equals 0.2. As we should find the 95% confidence interval, so the alpha is 0.05, and from the table we can find the alpha over 2 equals 1.96. So plug these numbers into the formula, we can get the answer, which is 1.7123 to 1.8877.
Hello everyone, my name is Lü Haoyuan and I'm responsible for Mock 3 Question 4B. In evaluating the consumer satisfaction level, a company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? From the question, we can know that The standard deviation is 0.8. The largest error is 0.05, and alpha is 1 minus 95% is 0.05. In order to calculate n, we should know that with base alpha over 2 times sigma over the square root of n, not larger than error. From the t-distribution table, we can know that when alpha is 0.05, that with base alpha over 2 is 1.96. Therefore, that with base alpha over 2 times sigma over the square root of n not larger than 0.05. That is 1.96 times 0.8 over 184.
I will now talk about questions A2. The manager would like to estimate the proportions of customers who like the new taste of drink in the next experiment. Determine the sample size such that the error does not exceed 0.08 with at least 95% of confidence. So we can use the probability formula to find the answer. Since the questions state that the error does not exceed 0.08, therefore we can use the less than or equal to sign to represent this meaning. If we want to find the sample size, we need to know about the sample proportions. However, the questions does not provide any sample proportions. Therefore, if we want to calculate these questions in standard normal, we need to assume that the sample is large and it is normally distributed. The next part is to find sample proportions. To find the sample proportions, we need to pick a sample proportion that is maximize this part as large as possible, because if we maximize this part, we can find out the largest value in this thing could ending of being. Then we can have a safer value. But how can we do that? To maximize the margins of error, we can set this part to equals to 0. Therefore, we can see that such that p times 1 minus p equals to 0, and we can get p minus p squared equal to 0, and we can take out the p, and we can have 1 minus 2p equal to 0, and we can get the final answer, p equals to 0.5. And the next step is to find alpha. As we can see in the questions want us to find the 95% of confidence. Therefore, the alpha is 1 minus 95% equals to 0.05. Step 3 is to find the set alpha over 2. So we already have the 0.05, and we can find 0.05 divided by 2, and we can get a 0.025, and we can find out that set alpha over 2 is 1.960. We already have all the information we need, therefore we can sub all the information into the property formula. 1.95 square root 0.5 times 0.5 over n less than or equals to 0.08, and then we can have 1.96 times 0.5 over square root n less than or equal to 0.08. As the left-hand side will multiply to the right-hand side, therefore we have to change the symbol to the larger to greater than and equals to sign. Therefore, n larger than and equal to 1.96 times 0.5 minus divide over 0.08 and square the whole part. Therefore, by calculations, we can get n larger than and equals to 150.0625. And we need to round up the value, therefore we can get that the n equals to 151. Therefore, we can get a final answer. The sample size is 151. Thank you.
I'm going to talk about question 4C. In this question, we're gonna use formula in confidence interval of proportions. So first, let X be the number of employees who like a flexible scheduling policy in the sample, and let N be the number of employees we choose from the population. So X is 300, N is 500. P hat equals X over N, and is 0.6. Q hat equals Y minus P hat, and is 0.4. In the question, alpha is 0.1, so we need to find Z subscribe 0.05 from the table of the standardized normal distribution. 0.05 is between 0.0505 and 0.0495. So Z subscribe 0.05 is 1.645. We put all the numbers in the formula, and therefore a 90% confidence interval is between 0.5640 and 0.6304.